Hey everyone, in this video we're going to learn how to solve exponential function word problems. In order to do that, we need to recall our function for exponential growth or decay is a equals p times the quantity 1 plus r to the t. So we have an exponential function, 1 plus r is the base, t is the exponent, that's our variable where we're going to input values, and again it's in the exponent, why we call it an exponential function, p is the coefficient, and that's all equal to a. Now let's run through what each variable represents. A is the amount at time t, so that's our final amount. P is the initial amount, or what we start with. R is the growth or decay rate per time interval. Important to note that it needs to be in decimal form when we use it in the function. So if they gave us a percent growth rate, so like 10%, we would need to use 0.1 in our function. A positive R value indicates exponential growth, negative R value indicates exponential decay. And t is the number of time intervals that have passed. So that could be in days, weeks, months, years, as long as it's consistent throughout the problem. If it's not, you just have to pick one time unit to use. So let's say they give us months and years, so either work in months or in years, and as long as you pick one or the other and stay consistent, the function will work. So in the previous video, we were given the exponential function and we had to answer questions based off that function, such as what is the initial value, what is the percent growth rate or percent decay rate, how much would we have after 8 years, after 10 years. Now in this video, we're going to be given a word problem and we have to create this function as our first step and then use that function to answer the question that the word problem is asking. So let's look at what that looks like. The local gym currently has 100 members. The membership enrollment is increasing at a rate of 8% per year. To the nearest whole number, how many members will the local gym have in 5 years? First thing we want to do is define our variable. So let t be equal to. So we need to pick a time unit for t. Well, we're increasing at a rate of 8% per year, and we're looking for the members in 5 years. So we'll let t be equal to the number of years. So the added level of importance to this let statement is we're choosing what time interval we're working in. So if we had a word problem where maybe we had 8% per year and then this said 5 months, well then we have years and months, but if we define our let statement to be years, then we convert everything to years. If we define our let statement to be months, we convert everything to months. So it's just a reminder of what time unit we should be working in. Now that we have that defined, we can create our exponential function. So a equals, p is the initial amount, so that's 100, times 1 plus, well, we're increasing at a rate of 8%. So positive R value, the decimal equivalent of 8% is 0.08 to the t. As a quick reminder of how to convert a percentage to a decimal, right? There's the decimal point. We can think of moving it 2 to the left, so 0.08, or we can think of 8 divided by 100, since percent means per 100. Both of these would give us that 0.08 decimal equivalent of 8%. Simplifying our exponential growth function, we have 100 times 1.08 to the t. So we know it's exponential growth because our base is greater than 1. We have a coefficient of 100, and we have our function set up. Now, how many members will the local gym have in 5 years? So we're going to use our function and plug 5 in for t to answer that question. So 100, let's fix that 0, 100 times 1.08 to the 5th. So we go to our calculator. So 100 times, in parentheses, 1.08. The exponent key is that up arrow to the 5th. and we have 146.93, 146.93 followed by a few more decimals. Okay, the question said to round to the nearest whole number. So if we round 146.93 to the nearest whole number, that's going to be 147 members. Okay, so after 5 years, this gym is going to have 147 members. Next, the hawksbill turtle population is currently 25,000 and decreasing at a rate of 12% each year. How many hawksbill turtles will there be in 15 years? So we'll start by defining our variable. So let t be equal to, so we want t to be equal to years in this case, so number of years. Now we're going to create our exponential decay function because we're decreasing at a rate of 12%. So a equals, the initial amount is 25,000. That doesn't look like a 2. That's better. 25,000 times 1 plus a negative r value. So I'm just going to write that as minus. And 12% in decimal form is 0.12 to the t. So you can write plus a negative r value. In this case, I just realized that adding a negative value is the same as subtraction. So a is 25,000. 1 minus 0.12 is 0.88 to the t. And we're trying to figure out how many turtles there are in 15 years. So we're going to plug 15 in for t. So 0.88 to the 15th. Again, we'll need our calculator. So 25,000 times 0.88 to the 15th. And we hit enter. So we get 3,674.34. So 3,674.34. Now here they don't tell us where to round to. Well, what we have to understand is we're dealing with turtles. Okay, so we either have a turtle or we don't have a turtle. So regardless of whether we have 0.3 or 0.7, 0.8, 0.9999, right, if we don't reach that next turtle, we don't round up because we either have a full turtle or we don't. So in this case, the population is 3,674 hawksbill turtles. So again, just to touch that rounding conversation again, doesn't matter if this is 0.3 or 0.9, we don't round in the traditional way. We're dealing with, in this case, turtles. Okay, so we can't have 0.9 of a turtle. You either have a turtle or you don't have a turtle. Okay, so that's why we don't round when we're dealing with turtles or people. We just use whatever the whole number we get without the decimal. A share in company Q is purchased for $31. The value of the share is decreasing by 7% weekly. What will the share be worth in 10 weeks? Round your answer to the nearest cent. Okay, so let t be equal to the number of weeks. And now we need to create our exponential function. So a equals p, which is the initial amount, so 31. And it's decreasing by 7%, so 1 plus a negative r value, or 1 minus. 7% in decimal form is 0.07, so minus 0.07 to the t. So we have a equals 31 times 0.93 to the t as our exponential decay function. And we're looking to determine how much the share will be worth in 10 weeks. So t is 10. So we'll plug 10 in to our function. So 31 times 0.93 to the 10th. So 31 times 0.93 to the 10th. So we have 15.003 and a few decimals after that. And they tell us to round to the nearest cent, so that's going to be $15. Okay, so the share is going to be worth $15 at the end of 10 weeks. Now they didn't need to tell us to round to the nearest cent here. We're dealing with money, so if they don't tell us and we're dealing with money, we're going to round to the nearest cent. If they tell us, they might say round to the nearest cent, round to the nearest dollar, then we do whatever the word problem is telling us to do. The population in irrational USA was approximately 410,000 people in 2000. If the population increased annually by a rate of 0.85%, what was the population in 2007? Okay, so we're going to let t be equal to the number of what? Okay, so 2000 and 2007 are years, but we want 410,000 to be the initial population, which means I want to treat 2000 as year 0. So I can do that in my let statement. Let t be equal to the number of years since 2000. And if we define t in this way, well, 2000 is 0 years since 2000, which is perfect. Now 410,000 is our initial population. And then 2007, well, how many years since 2000 is 2007? That would be equivalent to t equals 7. Okay, so that's a little bit different than how we define our let statement in the previous few examples. Okay, but by doing so, we're going to make it easier for us to write our exponential function, which is going to be a equals, so p is the initial amount, so now 2000 is year 0, so our initial population is 410,000, increasing by a rate of 0.85%. So 1 plus, now here's where a lot of students fall into a trap. Because they give us a percentage that is a decimal, a lot of students just write plus 0.85 here. But remember, it's a percent and we still have to convert it to decimal equivalent, which in this case we have to move that decimal point 2 to the left still. So we're adding 0.0085 to the t. So 0.0085 is the decimal equivalent of 0.85%. So our exponential growth function is 410,000 times 1.0085 to the t. So now we want to find the population in 2007, which we already established is t equals 7. So we're going to plug 7 into our function. So 410,000 times 1.0085 to the 7th. So we'll go to our calculator. 410,000 times 1.0085 to the 7th power. So we have 435,025, 435,025.9, and a few decimals after that. Now they don't tell us where to round to. But again, we had this discussion earlier. 0.9, traditionally we would round up, but 0.9 is not a full person. Hey, we either have a full person or we don't. So the population in irrational USA in the year 2000 is 435,025. That's it. We don't worry about rounding. We take just the whole number that we get. Okay, so if this is 0.9 or 0.1, doesn't matter. The answer is 435,025. Maria made an initial investment in a savings account that paid 1.5% interest compounded annually. If after 4 years she had $6,250 in her savings account, how much was the initial investment? Round to the nearest dollar. Okay, so first thing, let's define our variable. So let t be equal to number of years. Compounded annually is just a way to let us know that they're calculating the interest, the growth on the account every year. Okay, so compounded annually is calculated each year. So now we need to create our exponential growth function. So a equals p is the initial amount, and rereading the problem, they don't tell us how much she initially invested in the account. So we'll leave that as p for right now. And then we have 1 plus our growth rate is 1.5%, so the decimal equivalent is 0.015 to the t. So our exponential function right now is a equals p times 1.015 to the t. Well, this is definitely a little different than the problems that we've just completed. Well, what did they tell us instead? They said after 4 years, she had $6,250 in her savings account. So normally they tell us how much would she have after 4 years. We would plug 4 in for t and just go to the calculator. But in this case, they're telling us after 4 years, we know what she ends with, not what she started with. So we're going to use this information to set up an equation. Okay, so 4 years and $6,250. So 6,250 is our A value, our final amount, equals P, we still don't know what that initial amount was, times 1.015, and T is 4. Okay, so if we solve for P, that's going to be 6,250 divided by 1.015 to the 4th. Now we can go to our calculator. So first, let's figure out what 1.015 to the 4th is. And then we can do 6,250 divided by second answer, which is the negative key. Enter. And we get 5,888.65. So 5,888.65. And a few more decimals. Now they tell us to round to the nearest dollar. So rounded to the nearest dollar, her initial investment was $5,889. Okay, so this is what she put into the savings account at a 1.5% annual interest rate, and after 4 years, she wound up with $6,250. So the same process, but they just gave us different information. So instead of solving for the final amount, we had to use our exponential function to solve for the initial amount. Our last two questions want us to determine if each of the following word problems is best solved using a linear or exponential function and then solve. So we've already discussed earlier in the unit whether something represented a linear function or an exponential function. So we're going to tie that concept into word problems. So the first thing after reading the word problem that we have to decide is, are we writing a linear or exponential function? That's the biggest decision that we have to make. Then write the function and use it to solve. A catering company charges a $200 setup fee plus $15 per person for food. If you are throwing a party with 80 guests, how much will it cost? Okay, so they charge $200 setup plus $15 per person. So we'd be adding 15 over and over and over again. So we keep adding the same amount each time. So that indicates to me that this is a linear function. So now we need to define our variable. So let's use x in this case, not t. So let x be equal to the number of, well, they charge per person, so x will be the number of people. And now we're writing a linear function. So what do we need? We need a slope and a point. So f of x equals All right, well, $15 per person. That's going to be our slope in our linear function. So we have 15x, and then the $200 setup fee, that's the y-intercept. Right, so I'll write this out. So this is the slope, and that's the y-intercept. So we can write it in slope-intercept form as opposed to point-slope form. So we have 15x plus 200. So there's the function that we can use to figure out how much the catering company would charge per person. And now we need to use this to determine how much it costs for 80 guests. So f of 80 equals 15 times 80 plus 200. So let's use our calculator here just to make sure we don't make any mistakes. So 15 times 80, that's 1200. So f of 80 equals 1200 plus 200. So f of 80 equals 1400. So the answer to our question is $1,400 to hire this catering company to throw a party for 80 guests. Same directions, the next word problem. There are 64 teams in a basketball competition. After each round, half of the teams are eliminated. How many teams will be left after 4 rounds? So we start with 64 teams, and to get to the next round, we multiply by a half. And we multiply by a half, and then we multiply by a half. So we have repeated multiplication. So that means we're going to create an exponential function. So we need to define our variable, so let x, we'll use x still, be equal to, well, how many teams will be left after 4 rounds? So x is going to be the number of rounds. Now we need to write our exponential function. We'll use f of x again. So 64 is the initial number of teams, so that's our coefficient. To figure out the base of the exponential function, we have 1 plus or minus, well, we're eliminating teams, so 1 minus. And half of the teams are being eliminated, so we're decreasing by 50% each round. Okay, so 50% decimal equivalent is 0.5 to the x. So f of x equals 64 times 0.5 to the x. We could also write this as f, let's make that look a little nicer. We could also write this as f of x equals 64 times 1/2 to the x. Both of these are equivalent. Now some of you might have read the word problem and immediately thought to yourself, 64 times 1/2 to the x power. So you could figure out the base just from reading the word problem. That's fine. You don't have to use the 1 plus or 1 minus r approach here if you recognize what the base of the exponential function should be. But now that we have the function created, we need to figure out how many teams will be left after 4 rounds. I'm going to use the second function, so f of 4 equals 64 times 1/2 to the 4th. And the reason I chose this function to plug into is I think we can do it without a calculator. So 64, 1/2 to the 4th is 1/16. And 64 times 1/16 is equal to 4. So how many teams will be left after 4 rounds? There will be 4 teams left. Okay, so the main focus of this video is creating an exponential function from a word problem that we can use to answer the question that they've given us. Okay, so whether that's exponential growth or exponential decay is based on the wording of the problem. And then typically to find that final value, we need to use our calculator. And we might have to round, whether they tell us what to round to, or if we have to think what makes sense. And these last 2 problems tied in the concept of deciding whether we should create a linear or an exponential function. So the only way to get better at this is to do more examples. So go through, practice as much of these as you can, and make sure that you're confident in setting up that equation and plugging in using our calculator to get the right answer. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.